In today's episode, we're gonna continue talking about app call and cover additional topics. Okay, so let's get started. So here I have another application. I'm gonna use it to demo app calls. In the first case here, we're gonna be calling a function that takes a reference to an integer. So it's either an in or in out argument. How can we express this in app call? So to do that, we need to first make sure we have the function. So here in that demo, ref1 is properly prototyped. We have this, takes an integer pointer. And what we care about is if we pass an IDC number, it should return this number incremented by 1. So we can make then a variable. We can call it a if we wish. And we can say ref a. And here, let's first assign to it, let's say the value and say message a equal this number. And now after call, a equal the value here before call. This should be good enough to simulate that situation. So we're passing a reference to an IDC variable. The side effect will be carried back to us, and we should see the value 18 in IDA, and we should see as well the output, whatever that function prints. But first, let's just run the process. These are messages from IDC. Before the call, our variable was 17. After the call, our variable is 18. This is the expected behavior. So that's how we can actually pass by reference. Next, I'm gonna demo how we can app call non-standard prototypes. So, and in this example here, I have a function called ASM1 written using inline assembly, and it doesn't have a standard calling convention. So in IDA, this is going to be what we call user calling convention. But here we can see from the source code that it expects ESI and EDI to be input arguments, and it looks like AX is going to be the output result. So the function really all it does is AX equal ESI minus EDI. How can we do that app call as well without mess and nicely in IDA? All we have to do is make sure we have the proper prototype. So ASM1 is indeed in the database, compiled in. This is the actual compiled code looking exactly like the source code. But what we did here, we used the user code convention. And then we use, after the function name, we use the add symbol, angle brackets, the return register. Also, AX doesn't have to be the return register. We can rewrite that function, have it return in any other register. But that's how we are telling IDA where is the return. Then we're telling IDA there are two arguments, A and B. A is positioned at EDI and B is in ESI. And then what will happen is it will do ESI minus EDI. So let's see how that works. Let's go to main and put a breakpoint at main and run it. Now we're in a good spot, we can run it. So let's go to ASM1 and issue an app code. So here I'm gonna go down here and say ASM1 and give it, for example, 5 for EDI and 1 for ESI. And of course, it's a negative value because it's doing ESI minus EDI. So we can swap them if we want. We can say A is ESI and B is EDI. And now if I just recall them, it's going to be passed correctly. So 5 now will go to ESI and 1 will go to EDI. And now we should get a positive 4. And that's how we can call a user calling convention. Whatever you can express using the user call, you should be able to app call later on. Now, I did already demo the printf. Printf is a variadic function. So it takes as many arguments as it needs. And here in this database, I do have as well a user function called altsum. It takes the first argument and then an infinite number of numbers. So this is basically the altsum method. I don't care about how it's implemented. The point here is just to show you that in IDA, we can also support app-calling variadic methods. And so alt sum, and we pass stuff, for example. This function requires 0 as the terminator, so it knows when to stop, and this we can see it here. It keeps on pulling variadic arguments one by one until it finds 0, and it breaks out. So here, if I just naturally call alt sum, it would work. And let me show you that first. Again, let's remove the semicolon to see the result. And this is basically the output of calling this method. Similarly, as I told you earlier, we can call it with the lower level function. So dbg app call. We need to give it the address of that method. So let's see here. If we just say alt sum, it's resolvable. So let's try that. Second argument to debug app call lower level function is the prototype. And we saw that it does have a prototype. So the prototype is fixed. So we can pass 0. And now we are ready to pass the arguments like that. And we should have the same output. We should get the same value as if we called it directly, but we're calling it through the lower level function. Now I'm gonna talk about calling functions that may cause exceptions and how to deal with those. And this is gonna be an important mechanism that if we can use exception handling, we can intelligently leverage app calls to do fuzzing. So here we have a very simple function. All it does is really causes an access violation. So it always causes an exception. Now there will be functions that may or may not cause an exception, like ref1 actually. Ref1, if it does have a null pointer check, but if we pass an invalid pointer, it will crash. So just calling ref1 here in this method, as it is right now, let's clone it. Let's try to pass it a direct pointer value. So here, this is an invalid pointer. We're not passing null, so we pass that check. And it's gonna dereference 2, for example. 2 is an invalid address. This would cause an exception, but unfortunately my script might not necessarily continue up to this point. So let's run. And here we had a runtime error unhandled exception. And this is bad because I didn't get to run my script. I didn't have a chance to handle that and so on. So let's wrap that in an exception handler and show you how that works. Call a function that will always cause a crash. And here I will say, hey, we have a crash. So let's try to run this. It will be graceful. So here we can say that the script really did not abort you an exception. So even though this will cause an exception, we will resume nicely. So here we know we crashed and we continue the script nicely. Let's just dump E and just show you what we got from that exception that we got. We have a bit of high-level information about the exception. So we can get the address, the event ID. This is coming from a debug event, if you want to watch previous videos about debug events, and process ID, thread ID, and so on. A quick recap so far. What we covered today is more concepts about app call, how to call by reference, how to call variadic methods, and how to deal with exceptions. All right, so as well, I'm gonna be stopping at this point and leave a bit more topics for the next video. Thank you.